The question number 16 is the maximum acceleration of particle undergoing SHM described by the displacement equation y is equal to 4 sine of pi t plus pi by 2, where t is time in second is. Now dear student, if y is given a certain equation like 4 sine of pi t plus pi by 2, then the acceleration on double differentiation will be omega square, the repeated equation. So I write the acceleration of particle is equal to omega, this is omega, that is equal to pi square into the repeated equation 4 sine of pi t plus pi by 2. Now he's asking what is the maximum acceleration. So this become equal to 1, therefore the maximum acceleration of particle will be equal to, in magnitude, that is equal to 4 into pi square. And look at the option. The option 3 is equal to 4 pi square. So answer is 3. Now the question number 17 says that consider the following spring mass system. The masses m1 and m2 are equal to 2 kg. If the mass m2 is suddenly removed when the system was in equilibrium and in rest, then the amplitude of oscillation of the system will be. Now see, this is 2 kg mass, and 2 kg mass was exerting force equal to m2 into g. And once you release this mass, by Hooke's law, the k into the x, it will go up. And k into x is equal to m into g. Basically, this x is the amplitude. Because from here, now this becomes the new equilibrium position, and the particle with the mass m1 start oscillating about this position. So k into a is equal to m2 into g, and we have to calculate the amplitude. So a is equal to m2 g divided by k, and let's fill the value. The mass is 2 kg and g we can take roughly 10, and k is given to be 100. Therefore the amplitude of oscillation is equal to 1 by 5 meter, and 1 by 5 meter is equal to 20 centimeter. And the correct option is the option number 4. The question number 18 is the time period of simple pendulum is measured to be equal to 4 seconds. If the string of the pendulum is cut in 3 equal parts of the length in the ratio 1:2:4, and equal masses are hung from their respective end, then the time period of the shortest pendulum. Now see, the length, total length is cut in the ratio of L by 7, 2L by 7 and 4L by 7. And the shortest length is equal to L by 7. And the biggest length is 4L by 7. See, the original time period t is equal to 2 pi of root of L by g. And he says that the shortest pendulum, this is the shortest pendulum. So t, this would be equal to 2 pi, and L become L by 7 of g. And this is 1 by root of 7 and 2 pi root of L by g. And root of L by g is the original time, which is given equal to 4 seconds. So this is 4 divided by root 7 second is the option. And the first option is 4 by root 7. So answer to this question is 1. The question number 19, a traveling disturbance on the string is represented by equation y is equal to 2 sine of kx minus 80. T is the time in second. If the wave speed is twice that of maximum particle speed, then the value of k is. See, the particle, if the wave speed is v, this is equal to 2 times the particle speed. And see, from here equation, the wave speed is equal to omega divided by k. If you compare, then omega is equal to a and a by k. So I fill here a by k is equal to 2, and if this equation is given, then velocity of the particle is equal to omega, the maximum velocity of particle is equal to omega into a, and see what is omega. Omega is equal to a, and a here is amplitude, which is 0.2. So fill up the here value, because this was given equal to the maximum. So that is equal to 0.2 into a. So a cancel with a, then k is equal to 1 divided by 0.4, and that is equal to 10 by 4 is equal to 2.5, and your correct option is 3. The question number 20 is, assume that a police siren emits a sound of wavelength 2 cm if an observer moving with speed of 20 meter per second approaches a stationary police jeep which with its siren switched on, then the wavelength observed by the observer. Now dear student, when observer is in motion and the source is at rest, then you know that there is no change in wavelength. So wavelength remain unchanged. The change in wavelength is observed only when the siren, the source, would have been in motion. So it remains same. So answer should be 2 cm. So the correct option is answer 4.